Optical absorption, the quadratic electro-optic effect, and electroabsorption may have been measured in the non-conjugated conductive polymer studied, thus showing that doped PEP may have some future applications in nonlinear optics. Broadband luminescence spectra in the region from around 1000 to 1650 nanometer of lead sulfide QDS spread onto the surfaces of silica microstructured optical fibers have been reported. The PBS QDS luminescence spectra reveal blue shift and band broadening behaviors when increasing the pumping time duration, which represent the MOF lengths of 38 and 14 cm respectively. Broader and flatter luminescence spectra were obtained using a mixture of QDS. By maximizing the signal amplitude, MOF with PBS QDS may be used as an active optical device with potential application in optical amplification and sensing. Quantum tunneling refers to the quantum mechanical phenomenon where a particle tunnels through a barrier that it classically could not surmount because its total kinetic energy is lower than the potential energy of the barrier. One of the methods for achieving optical switching is based on quantum coherence and interference in the light-matter interaction. In conventional media, the main drawback of this technique is the weakness of optical nonlinearities and the high power consumption of the switching operation. OLEDs are a technology used in a variety of devices such as certain monitors, TV screens, and cell phones. Previously, linear chain polymers may have been used, but many limitations they suffer, mainly stemming from poor control over morphology, appear to be more easily controlled in dendritic structures. In the past, thin films of dendrimers may have been prepared by evaporation. This does not provide the desired emission due to aggregation. The introduction of peripheral alkoxy chains has been shown to enhance the solubility in organic solvents and the electronic density of dendrimers. A comparison is made between the dendrimers with and without its alkoxy addition. A novel dendrimer is prepared from the reaction of triphosphate and p-hexyloxybenzaldehyde in dry tetrahydrofuran and butoxide. This approach is chosen because of its good yield and all-trans configuration of the double bonds, which remove the need for isomerization steps. It was found that substituted dendrimer suffers no aggregation based on its absorption and emission spectra. The suitability of the films formed from using four different solvents is determined via both absorption and emission spectra, as well as visually with environmental scanning electron microscope, or the ESEM. It is concluded that the dendrimers containing the alkoxy chains result in a blue emission both in solution and in a thin film. This method produces materials suitable for the low-cost, large area, solution processed OLED displays.